In this section, we will talk about complex number and try to solve quadratic equation. So we all know the real numbers, right? So we have a rational real number, irrational real numbers. Now in this section, we will introduce a new number, okay, which is a imaginary number. So we have a imaginary number represented by I, okay, so this is a imaginary number, and this number I is defined as a square root of -1, or if we square both sides of this equation, we get square of I as a -1. So from this section onward, our I is a number, okay, this is an imaginary number, and this I is equals to square root of -1. Now when we use our calculator to find the square root of -1, does it give us the answer? It tells error, right? Our calculator give us the real number answer, but square root of -1, that is imaginary number, okay, and we use I to represent that imaginary number, or this is same as I square is always equals to -1, okay. So our I is a number, and this I is equals to square root of -1. Now if we have a number of this form, b times I, b is any real number, then we call it pure imaginary numbers, like 2I. 2I is pure imaginary number, okay. Square root of 3I, that is also pure imaginary number, okay. Our I is an imaginary number, and if you have a real number in front of I, then that is the pure imaginary numbers. Now here we have examples, and we are asked to write down these numbers as a pure imaginary numbers, okay. So writing in a pure imaginary numbers means we are writing in b time I form, okay. We must rewrite all this number with I, okay, in terms of I. Now we have a square root of the -36. Now at first you should be able to identify, is this a real number or not? Square root of 36, sorry, square root of -36, is this a real number? So if we have a square root of any negative number, then that is not a real number, that is an imaginary number, okay. So that is the easiest way to identify. Square root of 36, this is a real number. Square root of 36 is 6. 6 is a real number. But square root of -36 is an imaginary number. It is not real, okay. So if you have square root under the, sorry, if you have negative under the square root, negative number under the square root, then those number are imaginary. Now we will rewrite this imaginary number in terms of I, okay. So here we have a square root of -36. Now can we rewrite -36 as a -1 times +36? Do you all agree? So we have -36 under the square root. Now we rewrite -36 as a -1 times +36. We can rewrite, right? These are exactly same thing. Now what do we know about -1? Our -1 is I square. So let's replace our -1 by I square. So we have, for -1 we have I square, and we have 36 as it is, and let me rewrite 36 as a 6 square, okay. Any question up to here? We replace -1 by I square because that's how we defined our -1, okay. So our -1 is always I square, or our I is always square root of -1. So now here, let's find the square root of I square. So what is the square root of I square? I, right? What is the square of 6 square, or square root of 36? That is 6. So this is 6I. So 6I is same as square root of -36. These two are a same number, okay. So writing square root of negative 36 and writing 6i, these two are exactly same number. Okay, this number is pure imaginary numbers. Okay, and in the similar way, in part B, we have a square root of negative 8. So let's rewrite negative 8. We can rewrite negative 8 as a negative 1 times positive 8. Okay, the next step, we replace negative 1 by I square. So let's replace this negative 1 by I square. And we have 8, and we can rewrite 8 as a 2 square times 2, right? 2 square is 4, 4 times 2 is 8. Now here, now since this is a square root, index is 2, so we can, so every radicand with exponent 2. So this radicand has a power 2, this radicand has a power 2, so we can bring I and 2 outside. So 2i is outside, and this 2, its power is 1, so it stays under the radical sign. So square root of negative 8 is same as 2i times square root of 2, and this is pure imaginary numbers. Okay, any question in part A and B? Okay, in the similar way, we can rewrite number C. So here we have square root of negative 1/4. So let's rewrite this as a negative 1 times positive 1/4. The next step, we replace negative 1 by I square, then times 1 over, we can write 1/4 is 2 square. Now let's find the square root of each. So square root of I square is I. Okay, square root of positive 1 is positive 1. Square root of 2 square is positive 2. So this is same as 1/2 I. Okay, so square root of negative 1/4 is exactly same as 1/2 I. And these numbers, if you see I, then those are imaginary number, not a real number. Okay, that's how you can identify. If you have a negative number under the square root, that is imaginary. Or if you have I with a real number, then that is also imaginary number. Okay, now the next here, we defined a complex number. Now we have a complex number is in the form of a plus bi. Okay, so here a and b are real numbers. Now if we have our any number, okay, so if we have our numbers like, let's say 2 plus 3i, so this is one number. Okay, so this is one number, and in this number we have 2, this is a real number, and plus, and we have 3i, this is the imaginary number. Okay, and this combined 2 plus 3i is called complex number. Okay, real number plus or minus imaginary number, that makes a complex number. Okay, so in like here, so this is our imaginary, 6i is imaginary number, 2i times square root of 2, this is imaginary number, and this is also imaginary number. But in the image, along with imaginary number, if you have a real number, then it makes complex number. Okay, so 2 plus 3i is complex number. So in general, a plus bi, we write complex number as a plus bi. And in this a plus bi complex number, if our b is equals to 0, so if this b is equals to 0, what happens? This number will be a plus 0 times I. This is a plus 0, and a plus 0 is a, and a is a real number, right? So if your b is 0, then we have a real number. Okay, now if in the complex number a plus bi, so we have a plus bi complex number, and in this complex number, if a is 0, then we have bi, and we get pure imaginary numbers. Okay, so in any complex number, If b is equals to 0, that is real number, okay? And if in any complex number, if our a is 0, then we always get pure imaginary number, or that is imaginary number, okay? All right, so here we have an example, and in this example we are asked to rewrite this number in the form of a plus bi, okay? Now we have square root of 2. What kind of number is this? Is this real or a imaginary number? Square root of 2. Real, okay? The only way it can be imaginary is that if you have a negative number under the square root, or if you see I, okay? Those are the two things that tells you whether number is imaginary or not. Now this is real number, okay? This is irrational real number. Now we are rewriting this real number in this complex number form, okay? So we have to rewrite as a plus bi. Now can we rewrite as a square root of 2 as a square root of 2 plus 0? Is it same thing? Same thing, right? Now, so writing in complex form means we have to have a I, okay? Now we have a square root of 2, this is a real number, plus, and we can rewrite 0 as a 0 times I. Is it same? Now, is square root of 2 same as square root of 2 plus 0i? Is it same? It's same, right? Now this is the form is in this complex form, a plus bi form, okay? So here if you compare with a plus bi, your a is square root of 2 and b is 0. So if you have a real number, you can always rewrite that real number in a complex number form. Okay, now part B. What type of number is part B? We have 1/3 I. What type of number is that? Is it real or imaginary? Okay, so we have imaginary part. Now we need to have a real number with this imaginary number. So how can we have, what real number can we have with this imaginary number? Yes, right. So we can write this 1/3 I as a 0 plus 1/3 I. So here we have 0 as a, so our a is 0, so a plus bi, so our a is 0 and b is 1/3. Okay, so we have a pure imaginary number and we rewrite that in a plus bi form. So in part A we had a real number and we rewrite that in a plus bi form. Okay, now so we have part C, and here we have 1 plus root 3. Now what kind of number is this? Is it real or imaginary? Real number, okay. So let's add imaginary part, okay. So we have 1 plus root 3. We can always add 0, right? So this is very similar to part A. 1 plus root 3 plus 0 I. So here our a is 1 plus root 3 and our b is 0. So b is 0, a is 1 plus root 3. So we have a real number and we rewrite our real number in a complex number form. Okay. Okay, so here a is the real part. Okay, we call a as a real part. That's what we have in the next. And b as a imaginary part. Okay, so every a is a real part, okay, and b we call it imaginary part. Okay, so here we have now we have this number -2 plus 3i. What type of number is this? So we have -2 plus 3i. What is the type of number? It's a complex number. Okay, this is not a real number, it is a complex number, and we are asked to find real and imaginary part. So excuse me, finding real part means we are finding a and we are finding b, which is the imaginary part. Our complex number is always in the form of a plus ib or bi. Okay, So this is our complex number. In this complex number, A is a real part, B is a imaginary part. Now we have this complex number. Now in this complex number, can you tell us what is A and B? What is A equals to? -2. What is B equals to? +3. Okay, so B is the coefficient of I, and a part which does not have I, that is A. A is always has to be real number, okay, and B is the coefficient of I. So our real part is -2, imaginary part is +3. Now in the similar way, we have -I plus 4. This is also a complex number. Do you all agree? Now let's find A and B. So let's compare with A plus BI. Now what do we have as a A? So what is our A in this complex number? 4, right? So we can rewrite this as a 4 -I. Okay, so your A is +4. So A is +4, which is a real part, and B is the coefficient of I. Now what number do you have in front of I? Is it positive or negative? -1. So our B imaginary part is -1. Okay, now the next here we have negative is square root of 3. What type of number is this? Is it complex or real? How many of you think it's complex? So it's a real, right? So if it was square root of -3, then it would have been imaginary or complex number. But we have a -√3. So this is a real number. Now our target is finding A and BI. So what is A for this number? We can always rewrite -√3 as a -√3 plus 0I. Do you agree? Right? Now what is A? A is -√3. So this is A, and what is B? B is 0. B is 0. So from here we can generalize, like every real number has imaginary part equals to 0. If you are asked to find imaginary part of like a number 5, then it's always 0. Okay, so if you have any real number, or every real number has an imaginary part, and that imaginary part B is always equals to 0. Okay, any question up to here? So we have a I, that is a very new number. Our I is equals to square root of -1, or I square is equals to -1. Next, we have a complex number. Complex number is real number plus or minus imaginary number. So that is a complex number. We use A to represent a real part. We use B to represent imaginary part. Okay. Now the next here we have to. Okay. Now here we have in example A. So what is the type of this? What is this first number? So here we have 1 plus 2I. This is a complex number, right? We have 3 minus 5I. This is another complex number. Now what sign do we have in between these two complex numbers? Plus. It means now here we are trying to add one complex number with another complex number. Okay, so we have this first complex number and we are adding another complex number. Okay, so adding the two complex number. Now let's see how we add complex number. Okay, so we have 1 plus 2I, okay, plus 3 minus 5I. Now let's get rid of parentheses at first. We can rewrite this as a 1 plus 2I plus 3 minus 5I. Is it same, right? Okay. Now, whenever you are adding a complex or subtracting complex number, we add real part together and imaginary part together. Okay, now here, what are real part? Positive 1 and positive 3. These are real part. And what are imaginary part? Positive 2I and negative 5I are the imaginary part. So every time if you are adding or subtracting complex number, we add real part together and complex part together. So, okay, 1 plus 3, that is 4. positive 2 minus negative 5, that is negative 3i. So this is the new complex number after adding 1 plus 2i complex number and 3 minus 5i complex number. Now when we add two complex number, what type of number did we get? Did we get a real number or a complex number? Complex number, right? And in this complex number, our 4 is a real part, negative 3 is an imaginary part. Okay, now this is, so adding and subtracting of a complex number is very similar to adding like terms. Like in when we are simplifying the algebraic expression, we add like terms, right? We add x plus 2x, we add numbers together. It's this very same thing. So if you take your I as a variable, so what we did here, we added the terms with a I and we added constant together. Okay, so addition, subtraction, even multiplication of a complex number is very similar to the algebraic expression. Okay, addition, subtraction, multiplication of the complex numbers. Okay, now in part B, so here we have a root 2 plus I, this is a complex number, and we have negative root 2 minus I, another complex number, and we are adding these two complex number. Okay, so let's get rid of parenthesis at first, so we can rewrite this as a root 2 plus I positive times negative root 2, that is negative root 2 positive times negative I, negative I. Okay, we get rid of parenthesis. Now you just look for like terms, or you add real part together and imaginary part together. So this is real part, this is real part, and positive root 2 negative root 2, that is 0, right? So this is 0. Okay, the imaginary part, what is the imaginary part? Positive I and negative I, that is imaginary part. And if we, okay, positive I, negative I, what is that equals to? That is also 0. So this is equals to 0. So you are adding like terms. Every time if you are adding, multiplying or subtracting, you are adding the like terms. Okay. Okay, now in C we have I plus then negative 1. Now let's rewrite, let's get rid of parentheses. So this is I plus time negative 1, that is negative 1. Now can we add can we find the difference of I and 1? No, these are not like terms. Or here, this is our imaginary part and this is our real part. Okay, and they cannot be added or subtracted. Okay, this is the final answer. Now in D, here we have 1 plus I, this is complex number, minus 2 minus I. Now here we are trying to find a difference of two complex number. We have 1 plus I, one complex number, 2 minus I, this is the second complex number, and we want to find the difference of these two complex number. Okay, now let's rewrite without parentheses. So this is 1 plus I. Now you have a negative, so make sure to distribute this negative. Okay, so negative times positive 2, that is negative 2, negative times negative I, that is positive I. Now you look for the real part. So positive 1, negative 2, these two are a real part. 1 minus 2, that is minus 1. Then you look for the imaginary part. Positive I, this is imaginary part. I plus I, that is 2I. So this is how we add or subtract complex number. So basically simplifying the algebra. Okay, so you are looking for the like terms. Simplify the like terms. Okay, any question in addition, subtraction of a complex number? Okay, now the next here we have the multiplication. Okay, and so here if you have a multiplication of a complex number, so here we have a 1 plus 3i and we have 2 minus 4i. in between these two complex number we have a multiplication. You all see that, right? Multiplication. So we are trying to multiply 1 plus 3i and 2 minus 4i. Now here you can take this as a multiplication of algebraic expression. So we have two terms here in one parenthesis, and we have two terms in another parenthesis. We are multiplying binomial with binomial. And what method do we use when we are multiplying binomial with binomial? We use FOIL method. Okay, so since here we have two terms, let's use FOIL method. So you multiply first term, so 1 times 2, that is 2. Now let's multiply outside term, so 1 times negative 4i. So what is that 1 times negative 4i? Negative 4i. You can take this I as a x. Okay, you can take this I as a variable here. Now the next, let's multiply inside terms. 3i times negative 2 is 3i times positive 2 is 3i times positive 2. What is 6i? You multiply the number and I remains as it is, 6i. Now at the end we multiply the last term, which is positive 3i times negative 4i. And what is that positive 3i times negative 4i? That is, it's going to be negative 3 times 4 is 12, I times I is I square. This is same as multiplying the algebra. Okay, you just take I as one variable. Just forget about I as a complex number. Think this I as a variable and multiply. Okay, now let's go ahead and simplify. We look for the like terms. So here we have negative 4i, positive 6i. These two are like terms. So 2, negative 4, positive 6i. That is positive 2i minus. Now, what do we know about this number? What do we know about I square? Negative 1. Okay, I square is always negative 1. Now let's replace I square by negative 1. Okay, I square is always negative 1. So we have negative 12 times negative 1 because we have a product in between 12 and I square. Now this is 2 plus 2i, negative 12 times negative 1, positive 12. Now we do have a like terms, positive 2, positive 12. So this is 14 plus 2i. So this is the new complex number that we get after multiplying two complex numbers. The only additional thing you have to do here is that you have to replace every time. If you see I square, you have to always replace that I square by negative 1. Okay, if you have I, you can just keep I as it is. Do not replace I by square root of negative 1. But if you have I square, you have to always rewrite. You have to always replace that I square by negative 1. Okay, any question? All right, now let's go to number B. Now here, so we have a square root of negative 4. What type of number is this? Imaginary number, right? Times square root of negative 9. So this is also imaginary number. Now let's multiply these two numbers. Okay, and before you multiply, so if you before you multiply, you have to get rid of that negative sign. Okay, it means you have to rewrite this number without negative sign under the radical sign. Now how can we rewrite square root of negative 4 without negative number under the radical sign? And that's what we did very at first, right? Like if we go back here in very first example, we had a square root of negative 36 and we rewrite that square root of negative 36 as a 6i. Okay, now we use the same concept to rewrite our square root of negative 4. So this is, how can we rewrite negative 4? Negative 4 is negative 1 times positive 4. Square root of 9, it is negative 1 times positive 9. Okay, you can't have negative number under the radical sign, under the square root. You have to always rewrite. Okay, now we know what is negative 1. Negative 1 is I square. we can write 4 as a 2 square. We have a negative 1, which is same as I square. 9 we can rewrite as a 3 square. Now square root of I square and I square and 2, that is 2I times 3I. Now see, there is no more radical sign, square root with a negative number. Now 2I times 3I, 2 times 3, that is 6. I times I is I square. Now you see I square, you can't have I square, you have to replace it, and this I square is negative 1. So this is 6 times negative 1, 6 times, okay, this is 6 times negative 1, and which is negative 6. This is the final answer. So square root of negative 4 times square root of 9 is negative 6. Okay. Now, how would you multiply if it was, okay, something like, okay, just let, so for example, if we had something like positive 2 times square root of 2 times square root of 3, how would you multiply these two irrational number? What is the product of square root of 2 and square root of 3? So these are irrational number, right? Or the radical number. So what is the index of this radical number? 2, right? And the index of this radical number is 2. Every time if we are multiplying radical number, index has to be same, right? And in order to multiply this, we write down the radical number and then multiply the radicand. 2 times 3 is 6. So this is how we multiply if we are multiplying the real number. Okay, so these two, square root of 2, square root of 3 are real number, and this is how we multiply. But in our case, we do not have real number, we have an imaginary number. We have a negative number under the square root. Okay, so if you see negative number under the square root, you always have to rewrite that number in terms of I. Okay, and once you rewrite in terms of I, then only you can use the property that we use for this real number. Okay, okay, any question? Now the next here we'll talk the conjugate. Okay, now so our complex number is a plus bi. This is complex number in general. Okay, now the conjugate of this complex number. So conjugate of this complex number is, you switch the sign of I term, you switch the sign of imaginary part. If it's positive, make it negative. If it's negative, make it positive. Now here, what is the imaginary number here? Bi, right? So this is the imaginary number, its sign is positive. Now if you make it negative, so if you have a minus instead of positive, if you have a minus bi, then this a minus bi is the conjugate of a plus bi. Okay, that's how you find the conjugate of a complex number. You switch sign of a imaginary part. If it's positive, make it negative to get a conjugate. If it's negative, make it positive. So if we have a 1 minus I as a complex number, what will be its conjugate? What will be the conjugate of 1 minus I? 1 plus I. Okay, so what will be the conjugate of 5 plus 4i? 5 minus 4i. So every time you are switching the sign of I terms to find the conjugate. Okay, so if you have a negative I as a number, what will be its conjugate? Negative. So we have a negative I. Now you have to find the conjugate. You just switch the sign of I term. We have a negative I, just make it positive. So positive I is the conjugate. Okay. What about negative I plus 4? What is the conjugate of negative I plus 4? Positive I plus 4. Okay, the sign of I term switches when you find the conjugate, not the real part. Okay, you just flip. If it's positive, make it negative. If it's negative, make it positive. Only of I term. Okay, not the real part. Okay, now here we have a complex number negative 3 plus 2i. So this is a complex number, negative 3 plus 2i, and we are asked to multiply this complex number by its conjugate. Now what is the conjugate of negative 3 plus 2i? Negative 3 minus 2i. So we multiply this complex number with negative 3 minus 2i. This is the conjugate. Now make sure to have parentheses, okay? We have like a two terms. So you are asked to find the product of negative 3 plus 2i and negative 3 minus 2i. These two numbers are a conjugate of each other. Now I want you to multiply these two numbers and give me the final answer. You can use the very similar method, okay, that we use in our example 3, okay? So multiply these two complex number. So we are multiplying a complex number by its conjugate, and let's see what kind of number we will get here. Use the FOIL method. Multiply first term, multiply outside terms, inside terms, and last term. And look for the like terms. If you have I square, make sure you replace that I square by negative 1. And once you have the final answer, let me have that final answer. Do you have final answer? What is it?
I got 13.
Positive 13? Okay. So we have 13 as a final answer. Let me know if you have different than this. And if positive 13. Do you all have positive 13? You have a different?
I got 5.
Positive 5. Okay, so how about two answer? Let's finalize, okay? We get the only one answer. Only one is the correct. So we have 13 and 5. Do we have 13 or 5, or you might get some different number?
13.
So you got 13 too?
13.
13. So we are getting more votes on 13. Okay, and I think you can you just double check your answer for 5?
Yes, sir.
Does anyone need help in multiplying these two numbers? And let me know if you don't have 13.
Yeah.
Do you find it's 13? Okay. A different answer. Let me see what I haven't seen it. I'll be back.
Working on it. I'm working.
Okay. Can I see 13? Okay. 9. I see the 9 plus. Okay, now you have I square, right? I got the normal 8. So, okay, now you get the 13, right? And the 13. Here, okay, you have 13. Let me know if you need help, okay? You got 13, right? Did. Okay, let me see it. Oh, you need that. You won't get any grade if you skip these steps. Okay? If you have to find the correct answer, no grade. Okay, like even on an exam quiz, you have to show the detailed work to get the full credit. Okay, so writing the correct final answer is not what we want. 13. I see 13. Okay, does anyone need help here? So you multiply the first term, okay? First term is negative 3 and negative 3. Negative 3 times negative 3, positive 9. Multiply outside, negative 3 and negative 2i, that is positive 6i. Then we have inside term, positive 2i times negative 3, that is negative 6i. Then the last term, positive 2i times negative 2i, that is negative 4i square. So these two are 0, right? We know I square is negative 1. So this is 9 plus negative 4 times negative 1, which is positive 4. Just let me replace this by positive 4. Positive 4, and this is 13. Okay. Now, what we did here, we multiplied a complex number by its conjugate, right? And after multiplying complex number by its conjugate, what type of number did we get here? A real number, right? So this is so here we can make a general statement. So every time you multiply a complex number by its conjugate, we always get a real number. Not only in this example, every time we get a real number when we multiply a complex number by its conjugate. Okay. In our example 3, we did multiply two complex numbers, but those two complex numbers are not conjugate of each other. Do you agree? Since those two are not conjugate of each other, we end up getting a complex number. But in example 4, we multiplied a complex number by its conjugate and we end up getting a real number. Okay. Now, if we have a negative I and if we multiply negative I by its conjugate, what real number do we get? So we have a negative I as a number, complex number or imaginary number. We multiply by its conjugate. So what is the conjugate of negative I? Positive I. Now let's multiply negative I and positive I. That is negative I times positive I is negative I square, right? Now what do we know about I square? Negative 1. And we have a negative in front of that I square, right? So negative times negative 1 we get positive 1. And 1 is a real number. Okay, so every time when we multiply a complex number by its conjugate, we always get a real number. Okay, now in number 5, we have a division. Okay, we have to divide a complex number by another complex number. So here we are asked to find x divided by y. Okay, our x is a complex number 4 minus 5i. Our y is a second complex number 3 plus 2i. So let's find x divided by y. At first, we replace our x by 4 minus 5i. You replace x, then you replace your y by 3 plus 2i. 3 plus 2i. Any question here? You just replace x by given number and y by given number. Now, we have to divide here, okay? Now, when we divide, in our denominator, we have 3 plus 2i. And we have to, this is a complex number, and we have to make this complex number into a real number. We have to change this complex number into a real number. So here we have a denominator with a complex number. Our target is making that complex number into a real number. Now, how can we make a complex number into a real number? What do we have to do? That's right. That's what we did in part. So 4, right? We had a complex number multiplied by its conjugate. We end up getting a real number 13. So in number 5, we have a 3 plus 2i, which is a complex number in the denominator. Okay. So, and we can't have complex number in the denominator. We only need to have a real number. Okay. And to get a real number from a complex number, we always multiply that number by its conjugate. Now, we multiply our denominator by its conjugate. What is the conjugate of 3 plus 2i? 3 minus 2i. So let's multiply our denominator by its conjugate 3 minus 2i. Now, are we allowed to multiply only in the denominator? We have to multiply by the same number in the numerator as well. So we multiply numerator and denominator by 3 minus 2i. So in general, we multiply by the conjugate of denominator. Now let me rewrite this. So this is, make sure to have parentheses. We have more than one term. 4 minus 5i times 3 minus 2i divided by 3 plus 2i times 3 minus 2i. Now I want you to multiply the numerators together and denominators together. Very similar to number 4. So multiply 4 minus 5i with 3 minus 2i. and multiply the denominator. And if you need help, let me help you. Okay, those who didn't have a 13, let me check if you get 13. Yeah, okay. Okay. So multiply the numerators together. Use the FOIL method. Okay, multiply first term, outside term, inside term, last term. Look for the like terms. Get rid of I square by just replace I square by -1. Your denominator has to be a real number. Okay, if you get a complex number in the denominator, then it's wrong, because we have a complex number and its conjugate. So when we multiply a complex number by its conjugate, we always get a real number. Does anyone have a final answer in the numerator? What? In the numerator, we will get a complex number for sure. Do we have that complex number in the numerator? 13. Oh, 13 is the, okay. So we have the denominator 13, okay? So we have the final denominator is 13. That's a real number. We multiply complex number by its conjugate. Does anyone have a numerator?
I got
A guy. One of you, yeah. What is your, what number do you have in the numerator?
-7i plus 2.
Negative 7i plus 2. Okay, just let me rewrite this as a 2 minus 7i. Does anyone have different than this? So we have 2, so this is 2 minus 7i divided by 13. Okay, that's 12. That's a 10, that's 2. 15i, that's 8i. Looks good to me here. Okay, if you have different than this, let me know. Okay, now the final step. Now we just rewrite this. Now we give this denominator to each part. Okay, to real part. So we have 2 divided by 13 minus 7 divided by 13i. So this is the complex number that we get after dividing 4 minus 5i by 3 plus 2i. If you have different numerator and denominator, let me know, okay?